Hi. Completely unrelated to the nature of today's stream, Pianui and I have gotten into some sort of like shout out war. It's very funny. We both started streaming at approximately the same time and we're just communicating while the streams are starting. It's very silly and funny. At this point, we should just like do the stream together thing, but have completely separate streams that we're just doing some parallel streaming. We can't actually do that because Pianui is playing a game and is reaching like the finale of said game, and I don't want to get spoiled. Also, I'm in space. Well, regardless of that silly little bit of introduction out of the way, how's it going? We're back. We're doing this again. Record time, too. It's only been yesterday. Actually, wait, it might have been 2 days, but this is the next stream after the previous stream one. Yeah, where I have the sun, you have the night. That's the dichotomy we have here. That's how this works. Okay, regardless, we have business to take care of. We have accomplished a very important goal. We have prepared the solar bungle. And the solar bungle, in case you were wondering, just skipped to this stream in the series. This is an entire series, by the way. Is our dedicated observation satellite in low orbit around the sun, lower than any of the planets and at risk of melting. Genuinely, some of the solar panels got real close. Now, I'm not at the solar bungle right now. I'm at the lower stage of the solar bungle. Right here. Because I went to the tracking station and to do a cool introductory shot, as I do, and it says that this thing is on an escape trajectory. Which is interesting. I feel like logically that doesn't make sense. This should not have had enough energy to get into escape velocity, especially when we were trying to go to low orbit. So my only possible theory or justification is that the tracking station is lying to me, or it's done some crazy encounter with one of the inner planets and just started flinging off to infinity. Statistically, that's also absurd. So I think the tracking station is just lying to me. Either way, the solar bungle is available, and our first order of business is unquestionably to get some tracking data on the other celestial bodies. So let's do that. I know I've been trying and failing to design a general purpose system to calculate orbits while accounting for eccentricity. I am not actually going to use that today. I think I need to keep it simple, keep it clean, and just keep it going. So, start off our tests, we are going to go to the actual proper and existing solar bungle, and we are going to use the final min-miss strategy we created. The plan is simple. You can see, yeah, here's us being on fire. You may have noticed. So here's the plan. We are going to point ourselves in the direction of some celestial body. Just find its point in the sky and look at it. We are then going to time warp until such a time that that dot returns to being in front of us. Through this, and with some deviation due to the fact that we're physically moving, we should be able to get basically we're trying to physically determine the orbital period, but then through that determine the semi-major axis. Once we get the semi-major axis, and we know the mu value for the sun, we calculated it last time, we will be able to use the min-miss travel method to get to any particular celestial object that we choose to. Hopefully. I don't think it'll work on the first time, but I think that by doing this, we will be able to refine the semi-major and make it better in the future. So for stylistic purposes, and because it just seems like a good idea, our subject for examination shall be the ever-popular Duna. Provided I can find it. There's a good chance it's on the other side of the sun right now. Nope, there it is. Right over there. So, to do this, we need to get into our viewing position with our solar bungle telescope. Exact protocol for this is a little bit dicey. It's sloppy as all heck, but it has to be for the methods we're using. Okay, there's Duna. So next step, camera is focused here. We want to vaguely get Duna in our sights just so it's easier on the acquisition. Move to camera locked mode and then zoom in. Oh, wait, nope. Changing the camera meant that we lost our aim of camera. So now we enter the mechanism. Just sort of line it up like this. Okay. That right in front of us is Duna. Use the dot of the RCS to align the camera proper. I think that's as good as we're gonna get. Then we scroll in. We're gonna put the Duna dot right there. And now, theoretically, we time warp, but we want our time. Conveniently, I've paused it at just the right occasion. That we're on like a nice day-hour threshold. Let's see here. Do I have any old database for measuring these time? The anomaly 1 day, hour. I think for the purposes of this, I am going to steal the mood determiner. Because it kind of does what we want, particularly this part right here. We just want to translate the times that we're going to be doing here to regular periodicity in seconds. It means all these numbers will be absolute junk, but that's fine. So how about we copy all of this over here. Just want to check that all of these are still in the proper relative positions. That's just a number. Okay, so I'm going to take this lower one and I'm going to sort of reconfigure it to act as our semi-major axis detector. But to start off, let's begin by just putting in our data for all of these values. We are going with the MET of the solar bungle, simply because it's a small number. So 0, 130, 130, 0. And then all of this is to be determined. It will be an orbit count of 1, ideally, unless we miss it, in which case we can run it around again. We can make some logical inferences here. We know, just instinctually, that Duna is further away from Kerbin, well, from the sun than Kerbin. And because objects that have a larger orbit slower and therefore take more time, and we know that the orbit of Kerbin is 1 year exactly, we can assume, at the very least, that we will need to wait 1 in-game year before we see Duna re-emerge on our scopes. And that means there's a solid 1 year of game where I don't have to worry about it. But let's send Duna off on its voyage in 3, 2, 1. Actually, hold on. There's a part of me that wants to sort of record our current heading in case we lose it. So I'm going to take a little bit of a snapshot of the game to hopefully use as a way of realigning ourselves. Like, we can align ourselves with the star. We can do some stellar navigation if necessary. Okay, with that technicality out of the way, let us proceed in 3, 2, 1, go. I'm going to arbitrarily time warp forward until we get to 1 year, 130 days. Then we'll slow down and start looking for Duna. Now, as a reminder, 1 Kerbin year is different than 1 Earth year, but our mathematics already accounts for that, so that will not be an error. I saw a lot of retrograde movement by Kerbin while we were doing this, so I'm a little worried that our value will be, well, off by quite a bit. That's the problem with the sun being gigantic. Okay. We have gone almost exactly 1 year from launch. Well, from launch of this mission, not launch of the rocket. There we go. So now what we expect is to see Duna emerge eventually. I suspect, from the instinct that Duna is supposed to be a Mars analog, that we would expect to maybe need to wait another half year. There is absolutely no celestial body in front of us right now, which is interesting. Oh, Gilly's coming into focus. There's Kerbin. There's Moho again. Oh! I see you, Duna. Okay, to account for the variation, I'm actually going to mark every single point in time that Duna crosses our scopes. That'll give us at least a range if we use all of those orbital periods as our possibilities. Another thing we could do is bias towards the angle we were at when I started this, because I took a picture of the nav ball, and that should give us a measure of where exactly we are along our orbit. Plenty of options, plenty of options. I'm kind of focusing intently on this. For reference, it's about here, where we were in the orbit when we saw Duna the first time. Hold. Oh, it's close. One more orbit. In that case, slow us down. Come on, sun, get out of the way. I can't see the dot while you're in the way. I can kind of see the dot. We are extremely lucky. It seems like we're going to be able to get this at pretty much the same location in space for our satellite. Which is to say that Duna's orbital period is conveniently close to being a multiple of our orbital period. I am going to call it now. Okay. Checking my old screenshot. We were at about... Well, Navball Compass said we would be negative, let's say, 17 degrees to the horizon with the sky to our left. And that's slightly different to where we are now. But that is a Duna. So I'm gonna mark it. Let's see here. Year 2, day 80. Hour 0. I think we can assume some deviance here. I'm going to say 0 across the board for hour, minute, seconds. And that gives us an orbital period of that much. So, given that that's our orbital period, how do we get the semi-major axis? Well, I forget. I don't forget. I just don't remember the equation off the top of my head. And I also don't know if we've made a place in the spreadsheet to do it. I know we have. I don't know if it's in this one. I keep like adding and deleting everything, so it like comes in and out of existence. Well, the actual physical equation was a correlation between the orbital period and the semi-major axis. There's like a square root cubed form in there. That's always funny. Let's see if we have it. There's somewhere to put in a orbital period and a mu value. Phase angles. Trace. Anomaly. Ah, this looks like it. Right up here. Okay, so orbital period of that. A legally determined SGP of this. Guess we've done this a lot, huh? Maybe I shouldn't mess with this one. We got this. Yeah, let's just do it like this. I didn't end up using T2. I guess because I just assumed T1 was 0. That's fair. It's the equation. We want a SGP of the sun. There it is. Oh, nope. Paste as value, please. Period is what we just got from our orbital survey. The circle constant is same as it ever was. So this should be Duna's semi-major axis. Let's check that number and see if it makes sense. Which is to say, add some commas to it. Here we go. 20.7 billion. Now, I'm pretty sure we had a rough estimate of Kerbin's semi-major being around 12 or 13 billion. Seems like I opted to not write it down. But I do remember it. And that was just based off the us leg. the rough us exiting Kerbin's area. So if we want to do this number as our semi-major axis for Duna, I think it's close enough that we can start using it. And that is definitely getting a red, because that is like our rough estimate we just made. But it is actionable, and I will act upon it. With that, we can launch a liaison to go to Duna. And we can use the same Midmus strategy system to get there, or at least get close. Close enough that we can use the phase difference as we move to kind of narrow down its orbital period to exacter numbers. I don't suspect we need to make any changes to the liaison. But I might just make the liaison the solar bungle, the Tycho Brahe, without the tower. So we would go down to the Tycho Brahe and just load it in and be like, hey, you know this giant tower you got? Not canon. Ooh, I know. With that out of the way, we can put the boom on top. I cheated it. Cool. Now, oh my goodness, if the top of this thing wasn't opaque, this could have theoretically been our like extendable telescope. Real unfortunate we can't do that, but one day, maybe, it could happen. Well, anyway. So yeah, this one's gonna awkwardly be retconned down to the FE20 liaison. It's just like the liaison upgraded. Yeah, override. Okay. So we got the science kit. We could maybe arguably get rid of the barometer, but we might do an atmospheric entry. We might crash. Leave our options open. After all, this is our opportunity to get science from Duna. Okay. Any other things? We've been increasingly rejecting this lower stage. We might want to get rid of it. Better yet, make some upgrades. How about we get the larger SAS unit ring? Oh, this could be a great targeting reticle. Or like a super telescope. I think that'll do. Everything else is ready to go. Liaison's ready. We can redo the fairing to not make it freakishly huge. Now that our telescope mast is not part of the equation, just do a little that. Okay, we're ready. After a great deal of work, we are about to make our first attempt at going properly interplanetary. Map nowhere to be seen. If we pull this off, if this works, the ceiling of what we can accomplish raises significantly. Go big. Go far. In 3, 2, 1, launch. Alright, so we are away. Given the time that we're launching, we can't do... Actually, I've started to realize there is a sincere concern that we are going to overshoot if we just drain the engine to exhaustion trying to fly out. We could very easily overshoot Duna. And that'll just be an efficiency waste for all of us. I have an idea. We haven't talked much about it because we haven't really had a reason to, but there is some critical math regarding escape velocity and sphere of influence transfers. Because when you change sphere of influence, you're effectively changing the reference frame of your, like, trajectory and stuff. You would need to translate your vector outside of the SOI into a vector inside and vice versa. And the way you do that is actually kind of convenient. At least more convenient than you might think. Reason is, escape velocity is, in principle, like the threshold of escape velocity, is that speed which makes your orbit a parabola. And the nature of a parabola specifically, with regards to an orbital trajectory, is that your apoapsis is exactly at infinity with no excess. And your velocity at apoapsis is 0. You have exactly enough thrust to always be going further, but the further you go, your speed will never become a positive constant. It will become lower and lower and lower and get arbitrarily close to 0. It is only when you add a little bit more thrust to your escape velocity that you have excess speed exiting the sphere of influence. And that nuance is the trick. If we figure out our escape velocity, or actually no, if we target... There's a translation step here. Okay, so hypothetically, in the broadest scale, we want to make a Hoffman transfer from Kerbin's orbit around the sun to Duna's orbit around the sun. If we were Kerbin, with its velocity and everything, we would be able to know what velocity we would need to set ourselves to. We are not Kerbin. We are a tiny satellite stuck in the local gravity well of Kerbin. So instead, what we need is not velocity to take us from the Kerbin orbit to the Duna orbit. We need our excess velocity beyond Kerbin's escape velocity to be that change, that orbital change we need. So what we would want to do is go, all right, How much forward velocity do we need to add to go from Kerbin orbit to Duna orbit, assuming Kerbin had no gravity and we were free to just do it directly? We take that number, add it to the escape velocity of Kerbin, and that is the infinite apoapsis velocity we need to hit to leave. Our current Hoffman calculator does not accommodate for this. We will need to make some adjustments. And also, meanwhile, independent of everything, we're kind of like going into orbit. In case you were wondering what was going on. I'm waiting for apoapsis here so we can circularize. And again, I overshot it severely. Oh, like really bad. Okay. 175813. There is a nuance to this whole escape velocity business, is that we need to make sure that our escape is in the direction that we would want our excess speed to be added to Kerbin's orbit. Which basically means we need to make sure that we are going relative to the sun east when we're flying out of Kerbin. But that's as easy as just making sure that you launch the rocket on the night side. And if we're off by a few degrees, it's fine. We can correct. So needed velocity is 2132.5. We can do that. Oh, I've been... For some reason, I was looking for 2312. Let me just rotate myself around again real quick. I'm experiencing number misreading syndrome. Alright, good enough. We're definitely in orbit, so I'm not too worried about that. And now that we are in orbit, let's start activating our energy. That's the I-beam. I need the hinge. Expand out. And deploy. I think I left enough clearance. I did. Great. That should be our power. Ready to go. Now we just need to sort of try and calculate our objective here. So the sun is right there. Get a good look at it. And I'm gonna vaguely time warp until it's like Kerbin is centered behind us. It would be technically too late for our purposes, so I'll wait till right there. So this will be our moment of launch. Probably a bit too late. We might end up flying downwards, but it's okay. It'll get us the idea. Now we gotta do some math. Okay. First off, we never figured out the semi-major axis of Kerbin, but there's a very easy way to do that. We got this thing right down here. All we have to do is set this, just flatline all these values to 0, and then year 1. And it's a real good sign. Okay. Now we paste that by value over here real quick. Copy that. Then we go over to our same phasifier thing over here. One in there. I don't know, that's the output. Put it here. Value. And there we have it. This should beat Kerbin's semi-major access. It's pretty close to rounding up to 1360, so I think it's vaguely correct. So we'll put this as our semi-major for Kerbin, and I'm going to upgrade this to yellow. I feel pretty confident about it. Now, to figure out the excess velocity we need is a simple matter of taking this value, putting it in as our radius around the sun, then take Duna's supposed as our target. Let's get some commas on these as well. There we go. And these numbers look pretty correct. So there's some conversion here. This intends to give us our final speed, not our change in speed. But it's part of the equation. So 10203.9 is the speed we need to be at when we're done with the burn. Before the burn, we will be in Kerbin orbit, which is apparently 1985.1. So all that's required is to subtract one from the other. 908.80 meters per second of excess. How do we know what we're adding that excess to? Well, it's pretty simple. Given our current location is 199312 meters, we want our target to be infinity, which I will approximate by just putting a lot of zeros. It asymptotes. That's what that does. So we would need a velocity of 2971.2 plus the excess velocity we want at the end. This is not actually true. This is incorrect. We don't want the excess velocity at the start, we want the excess velocity at the end. And that's different. Let me check my equations real quick. This is a nuance I didn't think about. Let's see here. Maybe it works out. Yeah, okay. So, having looked this up, the proper term for the excess I've been talking about is the hyperbolic excess speed. And the hyperbolic excess speed is going to be our... You know what? I'll just write it down. I got a place to write stuff. So according to this, our hyperbolic excess speed, so our Vx for xx, is the square root of our velocity at any given time squared minus our escape velocity. So velocity escape squared. Now the escape velocity in this instance is whatever velocity puts you on a parabolic, which is that crazy high numbered 2971.2 basically. Our velocity right now would be the velocity we have. No. Okay, I see. We have this value. It's 918.80. We have this value. It is 2,971.2. We are solving for this. I see. This is our target. So let's just do some conversions on all of this. First off, we would want to square that. We can erase this line here. Oh, then this is going to be easy. So excess velocity squared plus escape velocity squared square root equals our target velocity for this burn. Which is interesting. It means that it has a right-angled Pythagorean relationship here. Where, I guess here's the escape velocity. Here's the excess. And then here's the velocity we want. That almost makes a weird amount of sense. Because you can imagine if our excess velocity is 0, then our velocity would be our escape velocity. We'd be making that parabola. And given that there's a lot of correlation between the conics and, you know, these triangular square things going on because of, you know, circles and sines and cosines and all that, I guess it makes sense that the relationship would somehow convert down to the sides of a right triangle like this. Interesting. Well, guess we use it. Guess I'm using it. So, in that case, what are the numbers we need here? So, this needed velocity. Let's just take that, paste as value. Just take that, paste as value. And then say that it is the square root of this times itself plus this times itself. And so the target velocity of our burn right here is 3,110.2. Very interesting. $3,110.2. Let's do it. Let's see if this works. Fire. It kind of makes sense. We are in a bit of a high orbit. Wait. Our apoapsis would not be infinite. Our apoapsis would start to convert out at the sphere of influence. So I should make the sphere of influence radius specifically the target altitude. What the heck happened here? Does that change anything important? It's 2957.2. Okay, 3096.65 then. A slight alteration. I don't want to overshoot or anything. 3096.65. All right, that's just about it. Let's see how we did. We'll learn once we emerge from the SOI. Actually, we'll learn pretty quickly as we get farther and farther out. Once we get past, like, Minmus or so, we'll see that our orbital velocity converges to the excess we wanted. It also appears that I'm pointing a bit down, so as I expected, I started the burn late. Just positionally, we should have done it earlier. Because we're not going to, like, a full perfect tangent line. That would be infinite speed. Okay. Our desired excess speed was 918. We got pretty close, maybe a bit more. Our speed right now is 9756.0, which is more than we were aiming for on the sun's Hoffman transfer. That makes sense, I suppose. Not too bad. We're a little closer to the sun than expected, and I imagine there's some sort of, like, angular momentum in play, but it's close. It's close, it's fine. We're also descending. So once we get to our periapsis here, we'll be able to do a normal Hoffman to fill the gap. We're almost there. Okay. 12818 million. Our target is Duna's calculated semi-major axis. .7. Our goal velocity is 10483.6. We can do that. So let's do that. 10483.6. We are going to have more digits in our velocities going forward. At least we still got the chemical stage. 10483.6. We're there. Now, theoretically, we should be able to go to the other side of the orbit and be at where Duna is. Duna will very likely not be there, but it's step one. Hey, I can see like the dots for the moon and Kerbin and Minmus circling around Kerbin. There's Moho over there. I think I saw Duna ahead of us. Yep. Oh wow, we're actually going to end up being quite close. This will do well for our desire to shift the phases. Though as we ascend, we'll slow down and it's still in front of us, so we're not going to hit it. Definitely not. Okay, nav ball. Looking for the... the conversion point is soon. It's a little unnerving that our radar connection to Kerbin is oscillating on and off. Like, oh. Getting a little more nuanced. Hold. Okay, we're basically here. So now that we are here, we want to make sure we circularize. Where's Duna, by the way? Where is Duna, by the way? It's over there. Look for a piece of red text that says Duna on it. Oh. Wow, it's right next to Kerbin. Those phases are interesting. Well, either way. 20469. Oh. Million. Target velocity of 7519.7. In 3, 2, 1, go. Too far. Maybe I should add like a really tiny monopropellant tank just to help maneuvers like this, but that would ruin our Delta V overall. Okay. Now we should be in a circular orbit, vaguely circling Duna. This is corroborated by the fact that our altitude is not really changing at all. It's a little high. If you're wondering what I'm doing, I'm waiting for Kerbin to be in a more ideal location. Oh, nothing. It must be behind the sun. No, it's not behind the sun. It's really far away. We're dead in space. Oh. Oh, the switch yard is pulled through. Barely, but yes. Fantastic. Okay, where's Duna? I mean, it should still be there. Oh, yeah, that was a great idea by me. Good job, self. That is complete lack of irony. I'm serious. Time warp to nil. Let's get eyes on Duna. What is its phase relative to us? It seems like it's 53 degrees. So the phase aligner. Okay, we need our radius right now. Radius is 20469 plus the sun's thing. So 20469 million plus the radius of the sun, which is that. Let's just say that plus that. Quick, okay. Paste it. It is in front of us. Angle is going to be 53. Let's say 53 degrees. I don't like that. Targetable periapsis. Like, that's basically undoing our insertion burn. So what we could do is we could split the difference. But that would require, you know, converting. Weird that I never calculated a way to do that. This is just an angle conversion. Hold on, let me see if I can do this with some basic numbers here. With 1, it obviously does this. If I get ratio periapsis to be a half, (90 degrees, 1/2). But the targetable periapsis is 1/4. So this ratio is what we can cheat. I don't trust it. I want to rederive this. We've done it before. We did it for our geostationary stuff. So let's see here. Definitely going to be dealing with the period of the orbit here. Okay. Yeah. So period of the orbit is equal to circle constant times the square root of semi-major axis cubed over let's get the whole thing as a square root of semi-major axis cubed over standard gravitational parameter. And if we want to go a certain wedge more or less on our orbit, that would just be a change in period of that much. So the modified period is the modified area, which is just going to be the actual phase angle, which I'll do as theta because I'm an original, divided by that, because this is like the full circle. This is our fraction of the circle. So this whole thing will be equal to circle constant square root of our apoapsis plus our periapsis, which I'm doing as radius up and down, divided by 2 cubed, and then whole thing divided by the standard gravitational parameter. So these will be equivalent. One of these will be the semi-major as we have it right now. This whole thing represents some like hyper ratio, which I'll do as capital R because I'm not creative again. No, I think it's circle constant times the ratio, which means the circle constant proper angle divided by circle constant. Because if the ratio was 1/2, it wouldn't be 1/2, it would be 1/2 the circle constant, aka pi. So this is correct. Then we get rid of it immediately, along with this. And then we square everything. So that'll give us the ratio squared. Semi-major cubed divided by gravitational parameter is equal to... let's just say the different radius plus semi-major cubed divided by 8 circle constant. Then we wipe out these, wipe out these. Currently at r squared a cubed equals radius we're looking for plus a cubed over 8. So next to that, we would do like the cubed root of 8a cubed ratio equals radius we're looking for plus semi-major. Oh, this is looking a lot more complicated than what I did before. So I do see a 2/3 term in it, so maybe not. We can do some simplifications right here. We got some cube terms in there, so this would be 2a cubed root of, forgot the square here, that ratio squared minus a equals the radius we're looking for. And now this is starting to look like the equation I have in here already. Because this whole thing is 2... Okay, well, it's semi-major times 2 ratio to the power of 2/3 minus 1 equals the radius we're looking for. And that is, in that form, the exact same equation we already have right here in terms of that ratio and that radius, which is good. Which means we can modify this as it stands. All these still got their correct. Yep, looking good, looking good. Okay, so insert here. What I'm going to add to this is a number to denote how many orbits we want until the phase connects. And the reason we want this is because sometimes we're so out of phase that doing a single orbit to correct the phase would cost too much fuel. So we won't. Oh, sorry. I've been focusing on the math so hard that I didn't see you come in. Hello. Right now, we're trying to rederive the phase to get our circular orbit to connect to Duna's circular orbit. We already have the phase aligner we used for Minmus, but I want to add a parameter to say, hey, don't do it in 1 orbit, do it in 2. Or 3, or 4, or 5. What do I word this as? Yeah, it's Duna time. Weirdly enough, the hardest part of this is thinking of a name for it. Orbits to phase. Default will be 1. But hypothetically, if we have it be 2, we want the ratios here to be cut in half relative to 1. So if orbit to phase is 2, we want this to be 0.75 right now. Thank you for turning on Excels. I'm just trying to remember how to, like, numerically do that. I can't just divide it by 2 because I don't want it to go to 2. I want it to go to 1. I could subtract 1, then divide it by this, and then add 1 again. That's a kind of hacky way of doing it, but not really in the mood to... -1 divided by 2 plus 1. How's these parentheses looking? -1 divided by 2 plus 1. Okay, that looks good. If I make this 4, it should be 0.85. Oh, no, I shouldn't divide by 2. I should divide by the actual physical value that's right there. Silly me. Yep, 875. Make this 3. 0.83, that makes sense. 1 is 0.5150. Excellent. Then we take... The only difference is that this is added instead of divided. And that should be 1.5. This should be 1.25. That should be 1.125. This should be... Yep. Okay. All right, good. We've modified our calculator here for the phases to allow us for multiple orbits. It's given us the correct ratios, and everything else hasn't changed, so the math is working. Now we got to try it out in practice. So to remember, our actual phase that we were working with here is about 53 degrees. So pitch down 53. Targetable periapsis is... This is the liaison. I've actually rebuilt the liaison, which is to say I've taken this Tycho Brahe and removed the mast, and now it's the upgraded liaison. It's just a regular liaison, but bigger. Actually, no, I'm a fool. This doesn't have the relay antenna on it. It's actually worse than the liaison, because it won't work for our relay. Darn, only realizing that now. Oh well. So, targetable periapsis that low is too low. How about 2 orbits? Maybe 3? 4. Okay. I'll take it. So we want a target velocity of 7,320.7 and then wait for orbits. Seven 320.7. Too far. Putting the thrust limiter to like 1% on this thing. I want to make sure that we hit the proper value exactly. Because we're going to be waiting approximately 7 years for this to align. Might as well get it right immediately. Okay. Now we're going to go radial normal, thrust limiter back to default, just so I don't forget. It's just because our phase is bad right now and Duna's orbit is long. Okay, so 4 years in 3, 2, 1, go. We'll keep track of, well, I mean, I guess it would just be the periapsis and apoapsis, but we'll know a year has gone by when the sun comes into frame. And I've made us aligned north-south so the solar panels will always get some sun. Now we wait. An interesting convenience that we can use the sun as the sundial like this. Pretty much all temporal measurement dates or traces back to the periodicity of the sun in some way. Orbits are big, they're periodic. You can't really affect them for an object large enough to reside on. And it's relevant to what you're doing. Okay, so that's orbit 1 of 4. I'd like to take this moment to confirm our assumptions real quick. So I'm going to run the numbers again, but with 3 orbits and see if the value is still the answer. Scientific betting is the best kind of betting. Because you can, like, prove you're right if you're smart enough. And if you're wrong, congratulations, you've unlocked a new field of study. Okay, I'm gonna call that 44 degrees. Just about. So back here, phase aligner, we go to 44 degrees, 1867, and then 3. 1844. Interesting that it's altered slightly. Wants our speed to be 7297.4. We trust it? How about another orbit, just because we know how this will go. Like, this is absolutely fine. We have the budget for correction burns. But this might suggest that our assumed semi-major axis of Duna is slightly off, which is something we will want to correct. It's part of why we're here in the first place. I don't like being in the dead zone for the satellite, but that just means Kerbin's really far away. We need to make a sister ship to the solar bungle. It's just another, like, relay jumper. I think we'll have enough windows to at least be able to confirm that this is working, that our method is working, and then we'll just build up the infrastructure. Which is to say, launch more relays. Maybe get more relay tech? We should be getting close. Oh, I know. We should be getting close at about when we get to 40 degrees. Because I haven't moved the ship since that measurement. Yep, okay. Alright, I think now we want to override the process and go for a full send. I could love to get a crosshair on this thing in the future. Assuming we're in line with the ship's heading, which we're not. Yeah, hover over the engine bell. That'll give us circles that we need to make concentric. Okay, then look for this. Okay, that's about it. I'm going to say a solid 30 degrees. So, 2 orbits, 30 degrees. 18393918. It's hovering around what it should be. What do we need for 1 orbit? 159. Fine, let's do it. Current apoapsis is 20469 as before. Target velocity is 7017.2. This is the shot. This is the shot. $7,017.2. Overshot it by a slight bit. Thrust limiter down to small. Raise our velocity by 0.3. We're there. Okay, moment of truth. We ride. I'm nervous. Like, there's no consequence to this going wrong in any way, but I'm nervous. Ooh, we might get an energy blackout from here. Oh, that's probably what happened. Not Kerbin being too far away. Just facing away from the sun. And the power ran out. Oh, no, we cut through that pretty easily. So maybe it is Kerbin being too far away. It would be terrible if Kerbin was too far away when we got to Apoapsis here. Hold. We're almost here. No, this is the periapsis. Never mind. We want Apo. We're halfway there. Oh, okay. Today we answer the question, or at least try to answer the question. Can we go interplanetary without a map? I don't see Duna. We're on the other. We're not there yet. We're 45 degrees away from it. Where's Duna? Where's Duna? I don't see Duna. I'm nervous. Where's Duna? Where is it? It should be nearby. It could be in any particular direction. There it is. Okay. It makes sense that we're in front of it. We're going slower than it. It would catch up to us. Can't tell how far away it is, though. We're here. Okay. What is its phase to us right now? We have no control over the vessel. I jinxed it. How close are we? When's the next? Kerbin's all the way over there. We're gonna lose the encounter because Kerbin isn't in a good place. I'm gonna warp forward slowly in the hopes that maybe it rotates around, we get direct feed. Where's the switching station? We're losing it. I can't even get the angle because I don't have heading control. The longer this goes, the worse it gets for us. We need to circularize. Come on, Kerbin. Come on, Kerbin. If we stay above sea level 20 billion, I think we'll be fine. That only means we got a few seconds remaining. I have an idea. I have an idea. This is dumb. But maybe we can boost ourselves. Step 1. Power electrics. I mean, that would be useful eventually, but... You. That's the antenna we're missing. $100G rating. We need 150 science for that. We don't have that. Okay. This is going to be an extremely silly construction. It's basically a temporary installation. I am extending the DSN. What do I mean by that? We don't have the materials to make our own. If we do not have signal, we will make signal. If our satellites aren't good enough, then we will use a lot of them. This is the correct music for this. Okay. Then we need a probe. I'm actually going to make this a person properly running the array as like an emergency task. Let's put like the lander can on the side. Listening to what the oops. Okay, how about this? Put that on. That on. Then this on. Who's up on this thing? I think that is. Okay. put this... Alright. Capro, you're an engineer. Let's get some... Get some electrics on this thing. Okay. Okay. This is dumb. This is silly. This is Kerbal. But is working? I don't know. It is my hope that this massive antenna array, this phase array antenna, will be enough to get a signal to Duna. If this works. Hi, welcome back. I just built... I will show you the plan. So the reason... Okay, we do want to get relays into Sun orbit eventually. The problem is that if we wait any amount of time, we won't have time. The ship will have moved. Because we'll lose the phase. So I need a quick solution. This is my quick solution. As soon as it loads. I have made a giant array of antennas. Hopefully, this can boost our signal enough to reach Duna. This is the plan. Catbro at the controls. The relay brick. It's actually more of a phased array antenna. So now we go back to the liaison and hope it's not too late. Also hope that this works, of course. I think we'll know pretty quickly if it's working or not. We get signal. We do not have signal. It might just be the wrong time of day. Warp a little bit. Like 3 hours. I don't think it's working. It didn't work. I'm calling it. It didn't work. Okay. Our job is now a lot more difficult now. We're going to warp forward until we get signal and then kill the time warp immediately. We are then going to try and circularize... Oh, oh, whoa, 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 whoa! We here. Barely, but we're here. Okay. Where's Duna? Okay, okay. Trust that we're not going to be able to do anything productive here. We just need to boost our orbit. Quickly. 19954 million. Up to the semi-major axis of Duna plus a little bit. $7,662.6. We do this. Wait, we're not... Right, we're not... Okay. I'll fix that too. Why are the rockets so wobbly? I should lower the gimbal limit. 7662.6. Yes? Yes. And I can't hear the engine again. Okay. We're back in it. The rocket is good. The rocket is saved. Now we're going to go a half orbit around and try to realign the Duna phase. At least for this part, our radar coverage should be improving. Yeah, not surprising given the distances involved. We're just reaching the physical limit of our satellites. Where's Duna at? There's Duna at. If I look really closely, I can barely see the distinction between Duna and Ike as it spins around it. Not sure how much of a sign of us being close that is. Oh! That was periapsis. Okay. So now Duna is behind us. Where exactly, though? Lock camera. For concentric circles. Good enough. Spin, align, tilt. Okay, alignment appears to be positive 11 degrees, which should be impossible, and implies that we are currently below Duna right now. So what did I even use that number for ever? Okay, so that's the sun radius. Our current altitude is 20468 million. Which added with the sun's radius gives us, in effect, a radius of 20729. Which is below what we set for Duna. So that implies that we are wrong in what the orbital semi-major axis of Duna is. Understandable, our measurements were pretty bad. Which means now we need to do the slow process of refinement. We are at apoapsis. Try and go forward. It is 10 degrees above us right now. So let's go to 20800. $7669.2. I like to imagine it means that Duna is physically close to us, but hey. We had to go through this process with Minmus as well. Our measurements weren't accurate. We did this sort of orbital squeeze theorem to get it proper. So we head over. I have an idea. In free camera, we go prograde, and when we time warp, we should tilt with the sun, which means we'll be able to know at exactly what point Duna is no longer above us circularly. And that will be our new lower bound for Duna's orbit. And closer to the center of the ship, please. Or just roll out. And stop. We are now tangent to Duna. We have like a circle that is our altitude right now. And there's a tangent plane at our point on that circle. And Duna is currently on it. Duna must be strictly above us right now. So Duna is strictly above 20761 million. Which means Duna is strictly above 21 billion. Interesting. Here's the numbers. Here's our current altitude. Here's the radius of the sun. So here is our objective radius from the sun. Duna is objectively above this. So I am going to mark this as we go. Same method we did for the moon and Minmus. So, this Duna orbit is now our new minimum. Also, give me some commas. I'm growing fond of the commas just to help read this better. So now we gotta ascend. So if it's strictly above 21022, how about we go to maybe 21500? What's our radius right now? 20761. All right, 7509.3. Wait, what? We have to slow down? No. We are not at apoapsis or periapsis. That's why. This doesn't make sense because of that. We're gonna have to wait till we get to the other side of the orbit. Did we overshoot by a crazy amount? We are much higher than I was expecting. We have bungled ourselves into a higher orbit. Did I misread a number? Okay, so we've overshot. I saw Duna like pass under us. I don't know how we got to this orbit. I might have just misread a number. But regardless, we're in it now. 22197 is our upper bound then. Well, 22197 plus radius of the sun. Is 261550000. Okay, so this is now our upper bound. So we're at Apo. We know a max and a min. It's going to help constrain it. So it's going to be somewhere in like the 21 something. Might be some parallax we could have done. I don't know. Let's go down to a solid 21 billion from wherever we happen to be right now, which is 22197. 7102.6. That makes sense. We need to accelerate. We've lost control of the vessel. We're in another blind spot. Okay, belay this. We're making that solar relay. Would love to have a little extra science so that we could splurge on the new antenna dish. We really need it. And yet, where are we going to get 150 science? We might need to do like an emergency mission to the moon, or Minmus. Just to find something. Just to scrounge up the extra science we need. It's suddenly very apparent the importance of getting these better satellites. Like, look at this. 100G versus 15. Okay, so it's comparable. We get like 8 of those on a stick, and it's comparable to 1. So nothing for it. Moon mission. Tenmo went last time, so wrong caught today. Actually, Capro is not required on this mission. How about we just do Enman and Roncott? Then we'll get these new satellites, we'll make them an upgrade to the switch yard, and then we'll be good to go. Quick detour to the moon to get some science. We're doing it. It shall be done in 3, 2, 1. Launch. Okay, for once, start turning early. You got a bad habit of turning too late and losing a lot of efficiency. We're turning early. I don't care if we overcorrect, we're turning early. More. Stage. Okay, looking good so far. Got a lot of ups, but not a lot of forwards. I think this will be a much better insertion than we've had before. Not sure by how much, but I think it'll be good. In fact, I'm a little worried we're not going high enough, but I think I trust that we are. We got the ups. Yeah, this was a good burn. Pause. Let's do this one by the book. 74927. Let's just get a nice 80,000. 2290. Good insertion. Let's go to the moon. This is all routine at this point, or at least I'd like to think so. As routine as it is, we cannot skimp on the protocol. That is what almost ruined the mission last time. Okay, 2 times ago. If I'm being correct. Alright, where are you hiding at, Moon? There you are. Maybe a little more. Okay, head to forward as we calculate our injection speed. Radius, semi-major is our target radius here. Actual altitude is currently 80597. For a needed velocity of 3132.3. Launch it. All right, we're there. Let's go. To moon. That's looking like a clean approach. That's a beautiful, beautiful approach. Splendid. All right, let's get the network up and running. Like to make some quality decisions about what I'm doing. Ooh, anomaly detected. Interesting. Cool. All right, I'm going to go for a polar injection. I know it's going to limit our options, but maybe we'll also unlimit our options. interesting. We're kind of dead on center for stuff. Okay, we are no longer colliding. We proceed down, we'll circularize low, and then we'll find a landing spot we're interested in. You keep up dating there, buddy. Okay, we're just about at periapsis now. Okay, 95850. That's actually pretty high. Versus our nominal of, let's say, 15,000. 430.5. We can do that. Pretty good. Let's see, we got some highlands, we've got some... The poles as before, the polar lowlands. We move over to the other side. There's highlands. Highlands. Polar crater! Now that's a tempting target. We gotta move the inclination of our orbit ASAP. I like how I can genuinely use this as like a GPS navigation thing. All right. So, polar crater. I don't see any landing sites of our path. I think we're home free. Now, our only complaint is that we're really high up, and so our delta V is going to be squandered because we didn't plan. But our delta V is high, so we don't have to plan. Oh, that's a beautiful view. Okay, so before we get ahead of ourselves, I would like to remind us that we need to get science from up here as well. Take your EVA report. Let's also extend the solar panels, just so I don't forget. We were lucky we didn't have any power problems on this mission, but I don't want to start. I hope there's no, like, consequences of hitting the remove from symmetry button. Okay, CurbNet. We are looking solidly in the middle of the polar crater. So we can effectively just drop anchor anywhere. That looks interesting. No, it might just be a shadow. Well, there's this relatively flat part right below us. Ooh. It's like an entire brightly lit crater. Interesting. Either way, I think we should start descending here. In the absence of any particular thing of interest, we may as well make landfall. Go down to surface velocity since we're intending to drop. Okay, I'm liking this landing zone. Let's just swap over to altitudes involved, 2 kilometers up. Relatively stable. Alright, I'm calling it. Prep for landing. Get our surface altimeter up. Alright, so terrain is about as flat as we could hope for. A lot better than the poles, I'd say. And it looks like the particular spot we're dropping down on is also free of some rock, so long as we keep stable. Alright, let's go down to our cruising fall. A little bit of an incline, but nothing so extreme as before. And touchdown. Hey, we did it. Nice. Okay, we have landed. Roncut, how about you stay in the ship? Edmund, we are here on business. Oh, the solar panels are now blocking the ladder. That's a design flaw. Cool. Fortunately, we don't need the ladder on Moon. We got jetpack. Okay, surface sample and EVA report. Excellent. Be so kind as to open the service bay. Thank you. Material study. Take that. The goo. Pressure data is available. Seismic data is available. Temperature data is available. Collect data, restore. collect data, restore. Now here's the trick. Swap back to here. Collect all. Then observe mystery do. Conduct material study. Keep. Go back. Collect all again. The first collect all was apparently frivolous. I messed up my order of operations. My apologies. Oh, nice air. Store these. That's okay. We can hold the rest. I just wanted to get rid of the EVA and surface sample. Yay. Surface sample. Check. We are good. Board. Okay, the science has been collected. Roncott, your pilot. Go out and plant a flag. Okay. I have a symbolic representation in mind for this location. So I'm going to use that. I just need to learn what the name of the place is. Okay. Obtained. Mining, developed, industrial revolution, strata. Ooh. The oldest intentional use of black coal was documented in Ostrava. So this shall be Ostrava. And the reason here is that we went here specifically looking for a resource. Not coal, but science, but... You know, it's a little more material of a mission than the others. Let's see, what's a good plaque for this? This whole thing is encoded as, like, logistics we're doing. I'm gonna put down like a... I'm gonna put the quote from Karl Marx. You know the one. I just think it's appropriate because we're doing like this whole thing for like we're getting these resources because we can, so that we can get connection to our ship out in the middle of nowhere. This is like a redistribution of wealth for the purposes of social betterment and access to distant locations. So, from each according to his ability, to each according to his needs. Cool. We are in the one place that hasn't been corrupted by capitalism. Space. I'm being melodramatic for no reason. Or being silly. Okay, let's get the heck out of here. Fair, fair. You know, space is big. It's going to take a while for capitalism to spread to all of it. All right. We launch. Okay, so what's our extraction? We're vaguely on the North Pole, so we vaguely want to go west. It's over there. So actually, we want to go this way west. Okay, we're good. So we rise and then we run. Small craters on the surface. I've only ever found 2 areas of study for the arm per planet. We saw the tree, there was a crystal I never got to examine. On Kerbin, on the moon, there was a small crater and a large small crater. And then on Nimnus, there was the little green sandstone and the olivine. Cut engines. Okay. Let's verticalize and then set our speed. Alright, we've made our own apoapsis. Let's run the numbers. We are at 105.43,000. And we want a target altitude of 30,000. Target speed of 184.1. It's always a little silly to me when I hear a velocity number that is roughly in the range that you would expect FM radio to be in. Especially with how I'd say the number as like 0.1. Because then it really sounds like I'm doing a radio show announcement in. This is 184.1 KSPC. Bringing you all of your interstellar tunes. That's even better, because K is like a proper letter for a radio station. It's like K and W, I think. And I think they're based on like what side of the Mississippi or something they're on. At least that's like US radio stations. But for other countries, you have radio stations that can probably encompass and broadcast to the entire country because it's physically smaller. You don't need like special stations that are on one side of the country that you have to repeat on the other. Though I guess if you want to get international radio, then that matters suddenly. So I guess there has to be actually some diplomacy between countries about who gets what radio bands. Neat. That's probably like a thing the European Union has to regulate. Probably something United States, Canada, and Mexico have to regulate as well. Alright, how's our approach doing? Oh, we're hitting atmosphere and it's looking pretty shallow. So, stage. Point, retrograde, surface relative, SAS off, we descend. I mean, the only reason they can share is because they're physically distant from each other. You can only really hear whichever one is closest to you, I think. So, like, you could have, like, a 184.1 on the east coast of the United States and a 184.1 on the west coast. Because if you're on one side of the country, you're not gonna get radio from the other. It just won't reach. Sure, it might bounce off the stratosphere a little bit, but it is not actually going to reach you. So you do have to make sure you're not overlapping for a given radius around where the station is. Otherwise, you're going to have interference, you're going to get both stations at once, it's going to be awkward. I don't know the range that those radios are legally operating to encompass. And so I don't know how much interference there would be per surface area. Something to research. Really something fun. I'm also aware there's like a whole like range of radio frequencies that's like specially reserved for just random people who want to mess around, communicate. Radio Discord. And of course there's all the non-radio frequencies that people use for other things like the internet, Wi-Fi, beam-in satellite communication, satellite TV, some frequencies from the sun that you just have to sort of ignore because the sun's too busy being in them, and naturally the ability to see light. That's a big radio frequency people are a fan of. Exactly. Had the same thought. Oh, I think we're loading in terrain. Okay, we're good. I always get a little worried when I have to remember that the game has to physically process stuff. I'm like, oh no, is it crashing? It's freezing. Mystery deepens. Okay, how high up are we? It looks like we're going to land in the ocean, given these values. Yep, that's an ocean landing. Got us in that. Oh, yep, there's the ocean. And splashdown. Okay, that is plenty of science. And all of it, okay, 550 of it, is going straight to best antennas in the game. We now have it. Anything else we want to get? We could buy supersonic flight actuators, precision propulsion. None of those are really relevant. A Sepratron might be nice on the moon rocket. I don't know. I'm not really here to improve our margins on fuel efficiency. I'm here to improve our margins on where the planets are. Okay. I guess so. But we already have the basic suite of actuators. Those actuators would mostly just let us put actuators on larger ships. Which I guess could help. Maybe more, like, positional control. Okay, open up the monstrosity we had before, except redo it. Okay, wipe these out. Voidma. Okay. New antennas. Maybe we get better hope of a connection. These things are huge. So each one of these lines having 6 would be 30, 60, 90. Each one of these bars is now equivalent to one of these antennas. So this right now is effectively doubling what we had before with just this alone. And we gotta make it bigger. That's too close. We are gonna need another interim. This has been decidedly obsoleted. Unquestionably. We shall continue to go big, lest we be stuck going home. Okay, based on my rough estimate, we have taken our old radar setup and multiplied its effectiveness by about 6. Alright, Cat Bro. You are on... Why are you saying you're not connected? We have crew capacity. It's this. There we go. Weird issue. Okay, we'll launch it. Let's see how good our connection is after this. Granted, we're always going to be limited by the antenna on the ship itself, which we can't change because we already launched the ship. It's at Duna right now. It's not at Duna, but it's like near Duna. You know how it is with rockets in space. Okay, ignoring the part where it's kind of really wobbly. This looks promising. Another inconvenience of not having the tracking station is I can't look at the radar network innately. So I have to physically go to the ship, see if it's working. We're ready. If this doesn't work for comms, we will make the solar relay immediately. This is the Duna liaison. I do hope we succeed. We get to Duna today. Because we're so close and we just need to narrow it down. First time is always the hardest. That is connection! We have control! Where's Duna? There's Duna. Physically below us. Alright, let's decide the plan. What orbit are we going to be aiming for right now? So, how about we go for target altitude 21 billion. What's our altitude right now? 22193. So, target velocity is 7103.5. I have to accelerate. That makes sense, though. Okay, first off, radial out so that we're back at legally apoapsis for maximum precision. Then, make the burn. Not difficult at all. Okay. Forward, 7103.5. Check. We go. Let's see how that radar connection handles over time. I imagine there will be times where the signal cuts out simply because Kerbin's facing the other way. But so far, it is looking phenomenally stable. There's Duna at. There's Duna at. Okay, we found a point in the orbit where our... Oh, it's operating off of its previously set instructions. That's neat. This is actually good for us. I wanted to see if I could do the threshold trick for Duna again. So there will be points where we lose signal. We can't use that tangent trick to say that Duna is objectively below us. Because it could be above us but far away. I was about to say we overshot, but it seems like we're heading towards 21 million radius and not... Because I'd never deleted it from the calculator. Right. When you put in a radius, it ignores the altitude. That's how the system works. I didn't delete the radius. So now we're down here. But we already know this is too far down. Though maybe not by much. Let's see what its angle says it is to us. Like, maybe we can try the phase at 21 million. See if that's good enough. No, it is objectively above us. Okay, in that case, let's target a radius of 21.5 billion. Starting at our current position of 20742. Billion. Sorry, million. 7514.4. We want to slow down. That makes sense. Soon we're going to lose power on the... We're going to lose fuel on the stage here. We only got 343 meters per second delta V left. As long as we're doing these, like, subtle adjustments, that's fine. 7594 to 7514.4. And, you know, once we lose this stage, we'll just go ion. Okay. Warp. Wait for 1/2 circle rotation. Watch what Duna's doing in the meantime. Oh, we could probably do the objectivity trick now, though. The camera is free. We are perpendicular. How perpendicular we be, though? Okay, a little more. Back of the ship, right click. Front of the ship. Use the magnetometer boom. Too strong. That'll have to do. Okay. Oh. I wasn't expecting that. Wait a minute. We're in a dead zone again. Okay. We are at 21252. Let's circularize here. Two 6-1. No. 7381.8. So now we're circular. And what I'm curious about is if Duna moves above or below where it is in her phase in one orbit. So we're looking at prograde. Let's wait till prograde. Let's see where it goes. Right now it's going up, but I think we'll only get best results if we wait around for it. It might be elliptical. It might have eccentricity. It's a question of what it's going to do overall. But it looks like we're gaining on it right now. That could change at any point, and I'm waiting for it to change. Halfway there. I know that on the stream side you can't see my cursor, but I haven't moved it since I started time warping, and you saw the text of me hovering over Duna appear. I'm just looking to see if Duna returns to that spot, which would suggest it's elliptical, or if it doesn't. If it doesn't, then it means that we are in our circular-ish orbit, fully below it. Oh, it's returning. It's returning. Okay, so that means that Duna probably is eccentric. Yep, there it is, Duna. So that's a problem. Time's coming up soon. Okay, we are back to Retrograde, and Duna has moved further forward along its orbit. I move the mouse down. There it is. And since that's the direction we're going, that means Duna is moving faster than us, which means that at this point in the orbit, and in terms of orbital period, it is lower than us. Which means we now have a new upper bound. 21252. Million. So that's actually very, very restrictive. We know it's between 21 billion and 21.5 billion, I think. I'm not sure if we can trust that anymore now that we know that Duna is elliptical. So we're more confident on the upper bound than we are the lower bound. How's about we cut the difference, go to the middle right now. So our current altitude is 21252, as we would expect. Let's go down to 250 less than that. So altitude 21000. 7360. We're gonna have to wait until we get signal. Oh, we got signal for the briefest of moments. Oh, this is like worst case scenario. Kerbin's like on the other side of the sun. I'm missing it. There's like brief moments. Okay. We have signal. Barely, but we have signal. We could lose it any second. We're going to go down to 7360.0, and we're going to coast. Okay, we coast. We go to the other side, we circularize, then we do another Duna orbit and see how it responds. There's Moho. What matters here is not how Duna moves. It's how Duna moves exactly one orbit later. Okay, we're here. Now we circularize. We're at 20999. We want to make that a circle. $7425.7. We're there. Okay, so once again, we point at Duna. There's Duna. Over the course of one orbit, we see what happens. We are aligned with retrograde, so we shall wait until we return to retrograde. Begin. We have to force ourselves to ignore what's happening now because we know it's an elliptical orbit. If I get into the SOI of Duna, I will probably try and enter orbit. Maybe I'll try and land on Ike or something. Like, we're going to have to do math once we get there, and that's going to need orbit. So I'm going to try and not just fly by. If we get into this SOI, I am definitely going to try and stick around. But mission success will be orbit, as far as I'm concerned. If we fly by, that's good. It means we'll get stuff. Yeah, you know, while we're there. I actually don't know if the ion thrust is going to be enough for Ike, but we'll try it. Priority, though, is getting the numbers, doing some extra science, but, like, getting the numbers. We're almost at periapsis again. stop. Once again, it has lowered. It has gone more forward. It is in a lower semi-major axis orbit than us. I think this means that our lower bound is perhaps bunk. Either way, let's log this in as 20999,000. And this is our no greater than. Our no less than, we are going to remove our confidence in and try again. Let's lower by 500,000. So we'll go to 20500. Oh, wrong one. $7381.4. We got no signal. We got signal. Good signal, too. Okay. Thank goodness this is a circular orbit. Otherwise, we would have some problems. But it's not, so we don't. I guess, but it is, so we don't. It is circular, therefore no problem. Anyway, 7381.4. We are away. Okay, we're there. Circle it around, circularize. I'm not going to raise the thing for this. You know what we're dealing with here. 20500 to 20500. 7514.3. Okay, we're ready for the next test. Where's Duna at? There's Duna at. Okay, we have lock. Get it more towards the center here. Okay. You're locked, ready. In 3, 2, 1, go. We are aligned to retrograde. We shall evaluate at retrograde. Halfway there. It's looking promising. It's currently above us. Oh, it's coming back. Oh. Oh, ho, 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 ho. I think we have it. Like, it's barely forward. It's ever so slightly more forward. But that's really close. That's really, really close. So, we're still above it. But I feel like this is good enough to be our estimate. Go 2500 million on this, and we can see that it is no greater than this, but that's really close. So much I am putting in this as our new estimate. From 2072, 2076. Wow, we were actually pretty close on originally. I guess it was just a problem of the ellipticality of it messing up our original estimates. Either way, I'm gonna upgrade this to yellow. Not yellow text, yellow highlight, I fool. Actually, let's do orange. Okay? Okay. It's on the lower end of its forward approach. We know this because it's kind of near the bottom. Okay, how are we gonna do this? The eccentricity is gonna be an absolute pain. What's it? I have an idea. What's its phase at right now? Point prograde, please. It's easier to reconcile. Okay, just looking at the camera, the phase is pretty bad. New idea. Slight alteration to the plan. I am jettisoning the lower... I am jettisoning the lower stage now. Stage. Now we proceed as we were. I'm going to try and use the solar panels as my alignment system now. Not easy to do, actually. I think that's it. I'm not sure. My plan here is to align the triangles on the mesh of the circular stage on the outside to the flat, like, edge of the satellite dish. Okay, having done that, where's Duna? There's Duna. Its phase to us is, I would say, 38 degrees. Let's work on that. 38 degrees. This is our new radius. So put this in the phase aligner. Okay. Target this radius from here. 6840.6. This is going to be a big one, but we're ready for it. 6840.6 in 3, 2, 1, go. The quality of our solar has degraded. We are too far. We're not going to have the electricity to do this burn. We'll have to go back to 2. Making a quick emergency change to the phase aligner. You don't see this, but I'm targeting a new periapsis. Okay, this only requires 7218. It'll have to do. Alright, fine, I'll do 3. Seven, 3, 2, 4. Okay. We are now experiencing a different technical flaw. First it was radio coverage, now it's solar coverage. We need bigger and better solar panels. More optimized for sun perpendicular burns. Alright, have a good going to sleep. Seven, 3, 2, 4.6. Yep, went too far. Okay. Now we need to wait 3 orbits. See how this goes. Nothing really to report, we just gotta wait for this to happen. One could argue we might try and be sneaky and make a attempt at a solar relay while we do this, but I don't want to miss it. Okay, we return to Prograde. There's Duna. Don't bother evaluating the angle. We're not going to do any other burns. If we get to Duna, it's very likely that the thumbnail will be Duna, so anybody who's watching the VOD will know that we've succeeded or not. I'm getting very Half-Life raising the bar vibes about that fact. Duna right now should be out relative to us. There it is. As we make these runs, sort of observe it, see what it's doing. I'm thinking about epicycles right now. With our assumption of Duna being a circular orbit, there's like an epicycle circle it's spinning around on to better reflect its actual elliptical orbit. And I think our best chance to encountering Duna is to put ourselves in the middle of that circle and then perturb it slightly. Duna will be basically orbiting us as far as we're viewing it, but in truth it's in an elliptical thing going in and out and around us. But as long as we perturb the circle only slightly, after enough revolutions, it should like alter itself such that we drift to the edge of the circle and it sweeps us up. It doesn't have a set radius, but it does have a set semi-major axis, which we have a decent measure of. So if we use that as our perturbed circle center, all we need to do is get into the middle of the circle. We can't see the middle of the circle, we can only see the edge. That might be good enough. Huh? It's behind us now. I think there's a good chance if we circularize at apoapsis, we'll be in the circle. That's only if it becomes underneath us. We're here. Okay. How do we circularize? 20500 million. 7490. Immediately. 7490.5. Where's Duna? There. We're close. I think we're in the circle. I don't know how long it'll take for the perturbations to reach us, but I think it'll be soon. $7,490. Something to do while I'm here. All right, 90 to go. We're about to arrive. Okay, the circle is set. Also, now that I have like some spare electricity, I can transmit the results of this. I want to get something out of my rocket. Even if we don't make it to Duna. Alright, where's Duna? There's Duna. Let's see what happens. Does it go under us? It looks like it's going under us. See Ike's orbit. Okay, so in theory, Duna just did a full revolution around us. Now it'll rise up and go behind us, and I'm just hoping that on one of these flies, it will just pick us up. Okay, so we did one orbit. I have a confession to make. I have once again accidentally put it in the target radius instead of target altitude. There we go. Now, granted, that actually doesn't change the value. No, yes, it does. Okay, apparently cut paste doesn't update values. Weird. And I can't fix it because of where we are in the orbit. We don't have radar coverage. Where's Kerbin? There we go. Okay, 7490.5 is wrong. We want 7514.3. That should be better. Hopefully, the perturbation hasn't been too much. Let's follow Duna some more. Oh, it feels so close. Should I chase it? I don't know if I should chase it. I think I know what I'll do. This is what I'll do. It's this strategy again. It's the same strategy we use with Minmus a lot of the time. We're gonna wait until it's like directly in line with us. And then once it is, we're going to phase to that exact point. Wait, this doesn't logically make sense. If it's perfectly level with us, then it's in that phase. Maybe we go for just matching the inclination, perhaps? Because we do have an inclination relative to it. Where's Duna? There. What's it doing? I flinched. I completely admit this fact. So it's below us right now. Spin around. I don't know how to get closer. Like, we're stable here. It's circling us. But if I change anything about what I'm doing, that will change. I believe that eventually we will get an encounter. I just don't know how many turns of the circle it will take. Making a change. I'm making a change as soon as we get... There we go. Nope. 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 We are speeding up. I'm going to lower our target altitude, which is to say the other side of the orbit, to 2040. 7505.2. The reason I'm doing this is that when we accidentally bungled our insertion burn into the circle, we got real close to the front edge of the circle. And we know from experience that the actual semi-major axis we're using is too high. Which means as the circle has just been allowed to propagate since we corrected it, we've been drifting away from the front. I'm hoping this will let us start drifting towards it again. We have to figure out the right way to perturb the circle. Oy. We feel so close. And yet... got a long ways to go. This is kind of what I was afraid of. Just our inability to reconcile with ellipses and inclination and stuff. At the very least, this confirms that we're still inside the circle. So this is not too extreme of a change. And our inclination at this point seems relatively okay. So we'll do another lap like this. I'll be honest, I'm getting disoriented following this dot in the sky. Steady. Steady. Maybe it's not enough. Wow, you can make the field of view go real weird. Can't actually figure out what my field of view even is right now. It's not like a convenient number. There they go. I think I'm gonna lower it more. To 2030. Speed now would be 7496. .1. Okay, let's wonder if that has ruined it. We'll be able to tell soon enough, and if it's too much, we can go back. It's just hard to measure our progress with no, like, distance measurement capable anything here. I could try and get a read based on how much the word Ike, the text Ike on my screen, is warbling. That seems like an absolute pain. Instead, what I'll do is let this perturb some more, and we'll know if Duna does not go underneath us, then we've gone too far, and I'll double it back over to 2050. This has really come down to a lot of precision work, huh? And this precision work isn't just going to go away, because we need to figure out how to deal with the eccentricity. So far, so good. Duna is descending. Will it go under us? Will it eclipse the sun? Prospects looking good. Okay, it does eclipse the sun. Technically, there's, inclination to deal with, but that does mean we're still in the circle. And Ike's movement is looking fairly extreme. It's possible that on this orbit we will exit the circle, at which point I will return us to 2050, 2050, and, like, step us backwards. Worth noting that it feels like Duna spends a fair bit of its time behind us, indicative of us being on an edge of the circle. Okay, angular velocity is still positive. If it goes negative ever, we might be in trouble. Ike is very much far away. As it descends to below us, as we know it will slice under the sun and hopefully catch us. Moment of truth. It's fighting it. Radial negative. We have exited the circle. Repeat, we have exited the circle. We need radar coverage immediately. We have signal. We need to accelerate. Back to 20500. $7514.3. It's not lost on me that our actual position is actually 20502. So I will fix that. So our actual target velocity is 7513.8. Okay. Let's hope we have fixed the circle. Oh, it's so close. Slightly behind us. I wonder if the problem is inclination at this point. Okay. We're back in the circle. So that means we should lower ourselves again. I'm gonna go back to 400. That was a decent middle ground, I think. 7504.7. Look at it. Look at it. I can see the planet physically. I can see Ike physically, probably even. It's so close. It's spin. I'm going to do something unconventional. I'm going to take a blind shot at correcting the inclination. Do I know any inclination math? Seems like there would be some way to convert, but I don't think it's as clear-cut as there's just some equation. Nothing simple. Yeah, okay. We are left to do this blind. Okay. Okay, so arbitrarily I burned for 15 seconds and we're gonna see what happens. Actually, I think I burned the wrong way. So let's truly hope that did nothing. Right there. Like we are on the edge of the circle. Just gotta like fix things like inclination and stuff before it's too late. So here's the plan. The moment it lines up with the edge, I'm gonna try and burn for, I guess, 45 seconds, considering the last one didn't work. And I went the wrong way. Okay, close enough. It's heading that way. We follow it that way. We are going to do a burn for... Actually, I'm going to say a minute. Actually. Camera on this. Solar panels aligned. We are anti-normal. Where's do not right now? There it is. Okay, not yet. A little more. Here. 60-second burn in 3, 2, 1, go. I'm just counting this. Pretty sure I'm counting wrong, too. Doesn't help that I keep trying to talk while this is happening. It'll be close enough. It's messy work anyway. Alright, I'm gonna say good enough. Let's hope that did the trick. Immediate good sign. Duna appears to be a lot more in line with us. That was very lucky then. Now the question is, are we still on the edge of the circle? Dicey. Dicey. Very, very dicey. We might be outside of the circle. Come on. We're rising. You're lowering. Gain that speed. Go under us. Angular velocity is still positive. It went positive. It went positive. Okay, we are just barely outside of the circle. We have no control to speak of. Speak of it. Speak of it. Power. Radial out. We need, like, perfection here. Okay. We are currently at a 499,400. Let's go to a 499,450. Just raise it a little bit, see how that changes things. Target velocity is 75,110. Okay. At the very least, the inclination feels fantastic. I can see the planet. There it goes. Off to be a dot in the sky again. Okay, next circle. Coming up. Are we in? Looks like yes. That's definitely in the circle. Oh! We're here! We're here! Oh my goodness. Okay, okay, okay. All right. Okay. Okay. All right, where do we even start? All right. Well, I think we should start basically how we would start with the moon. Which is to say, let's just get ourselves captured. I think best way to do that is to... Well, it's going to be tricky because we don't have any parameters on this thing. But okay, okay. We have signal, at least for the time being. So let's say radial out. Surface radial out. Oh no, we're leaving. I must have time warped too far. Oh well. I guess I didn't really expect it, to be fair. So get ourselves recaptured. We really don't want to leave this orbit, otherwise we are going to have no idea what our actual parameters are. Just in case we do not stay here. Let's just get the science. Alright, we're not on the ground. Save all our energy. We need it for the burn. Sun's in a terrible spot for this. Okay, we're at a throttle where we are gaining electricity. It's a very low throttle, but we're in space. We got distance to burn. We also know that the SOI of Duna is at least 31 million kilometers. Sorry, 31 million meters. I suspect it's actually higher than that. I know that the mass of Duna is less, but it's also further away. I don't know if it's going to be larger or smaller than Kerbin. But even if we do lose this, any amount of velocity we reduce is improving the odds of us getting captured again. I was afraid of that. We've lost control of the satellite. I do think I have a way to cheese this, though. Okay, I'm performing the cheese. Cheese is performed. I've cut the engine by time warping. If I untime warp, the engines turn back on. So actually, we can still do this mission. All I gotta do is time warp on and off to control the engines. If I keep the electricity above 0, I'm not worried about the ship losing power. This is really funny. I effectively have a way to reload the power of the ship. We're pointed in the right direction, so basically we just keep doing this until we're circular. Or at least something close to it. hopefully we'll stall for enough time that Kerbin can spin around and we can re-access the network. We'll also know if we get established connection to Kerbin again if the engine suddenly cut off. Because now it'll know that we're not ordering it to fire. And we continue. Just keep doing it. Starting to get worried that we have too much energy and I should have burned slightly more retrograde instead of radial down. Okay, our acceleration is increasing now. We need to establish contact. We're now functionally forced to time warp until we get a signal. At least we've stalled the problem. Oh! We have signal? Okay. Now we have to sort of arbitrarily eyeball it. But first, let's transmit data. We ain't getting the ship back. All right. I just thought of a really funny way to sort of like approximate this. So, what do we know about Duna? What instincts do we have about the planet Duna? You want to know my instincts about the planet Duna? Here's my instincts about the planet Duna. It is more mass than the moon, but less mass than Kerbin. That is my instincts about the planet Duna. So, what does this mean? Well, we are currently in a 31555 orbit. So if we were in a 31555,000 orbit of Kerbin, and we wanted to circularize that, we would need a speed of 331.2. if we were in a 31555,000 orbit of the moon and wanted to circularize it, we would need a velocity of 45.3. So I think this is our bounds. The true, proper circularization speed that we want is between these two. This is a lot less helpful than I was hoping it would be, because our speed is already within those bounds. I personally believe that these bounds should be biased towards the moon, simply because I think Duna is at least pretty significantly lower mass than Kerbin, and I think that scales in a more than linear way with our velocity. Really, though, there's no way for me to know. Actually, there is a way for me to check. If I go radial in and turn this into an apsis of some kind, we will be able to check immediately if that apsis rises or lowers by just time warping a little. And we are ascending. So we know it needs to be below 193.5. You didn't really see that, but we are ascending. We are now at 31556. So let's go down to, say, 150 and try this experiment again. Let's make our orbit cam auto so that we'll know vaguely what's up. It seems like orbit cam thinks we're in orbit already. Well, auto cam. Let's stop at 160. Okay, we are at 160. A quick radial in to put our apsis right here, whichever one it happens to be. Okay, and warp. We are still rising. So reduce speed more. Let's go to 120. If you're wondering why I'm being so cautious instead of using the auto cam, it's because I really, really do not want to hit Ike. Ike, relative to Duna, is very close and very big, and it will ruin our orbit with an encounter. So we need to do this high and safe. Okay, so radial in, get our apsis recentered. That'll work. Still rising. And we're out of signal. We also appear to be going retrograde. Wait for reacquisition. There's reacquisition. Retrograde us some more. Let's go down to 90. Okay, and then radial in to reset our apsis. A lot more susceptible. Okay, let's do this. Oh, that's practically circular. Okay. Welcome to Duna! Glad you could stop by. Okay, now let's start doing the measurements here. Our measurements aren't going to be that good because we're in a high orbit, but we need something to work with before we can start doing maneuvers. Now, I know I set my velocity to 90 flat, so we're just sort of waiting on the apoapsis. I think is 31605 to our radius survey. With a speed of 90.0 and our classic 0.05 there. Next up. Oh, no, it's nope. I'm sorry. These are the apoapsis values. Okay. So I'm at the table. I'm filling it in. We got the apoapsis values as far as I am understanding them. 31605,000. Error is going to be 500 naturally. Velocity is a flat 90 and everything is good. So we go to periapsis now, which I shall cheese locating by doing the prograde becomes retrograde trick. It just helps me get into the proper ballpark. Two, 3, 6, 9, 5. 119.7. 2, 3, 6, 9, 4. 119.7. 9, 3. 9, 2. 9, 1. 9, 1. Okay. And 119.7 throughout. Oh. So 23691,000. I appear to have broken it slightly. This is probably because of the copy-paste job I did earlier. Let's just do it one lower. 23691,000, 500, 119.7, 0.05, 31605,000, 500, 90.0, 0.05. And we'll just delete that one. Okay. So, significant figures on this one. It's looking like it's going to be a 3, just because of our low velocity. Tragic, really. Okay, so it seems like the radius of Duna is going to be 291,000, give or take 98,000. That's really not good bounds at all. If we're going to be doing this good, we need to get much closer. Actually, just based on these numbers, what does a Sig 4 look like? Yeah, the error bounds is just bad right now. We gotta get closer. But now that we're here, at least, safely, stably, let's work on the network. I think it's earned it. I think at bare minimum we need to do two things. We need to get a new switching satellite for Kerbin, and we need to put a switch yard into low sun orbit. Wow, I've been streaming for 5 hours. It did not feel like it. I guess I should wrap up eventually. We should absolutely get the electrics research if we're going to be doing more ion stuff. Okay. The new switch yard will be derived off of the liaison frame, which is sort of becoming our international probe frame system. And it makes sense. Load up the liaison. Okay, first off, new electrics. We need to account for this. 8.3 per second. We have been using these, which are 1.6 per second. That's the huge one. 24.4. So 1.6 per second times 6 per wing. That's like 9. This is going to be doing near triple that with just one. Which means get rid of those, get rid of that. This entire assembly is no longer necessary. That's fine. Okay. Next step. This is going to be the switch yard version. Actually, no. We can make the liaison first. Ooh, those antennas extend big, though. Maybe I shouldn't be surprised. I'm fine with that. It's just a matter of figuring out where to fit them. If I do this, they're going to hit the solar array. Maybe I just make the solar array taller. Use that, like, I-beam long edition. Well, it's pocket edition as far as it's concerned, but it's long edition and longer than the I-frame. Maybe there is still room for hinge technology here. So let's say 90 degrees. Here we have a closed position, and then I don't think it's necessarily a bad thing that this thing comes flat packed. Ooh. Almost. Gonna need a little bit of extra distance. Okay, well, seems like despite everything, the iframe is returning. So this configuration won't matter too much. After all, proper operating angle is this. Bearing's gonna have a little jank to it, but not too much jank. I think it's an acceptable jank. Wait, what am I doing? That's not gonna work. We go for like a an uneven angle. Strike wire in it. So we do that at this exact angle of like 55. The antennas will fit. This'll fit. May even be some secret advantages to this that I don't know about. Okay, save for clipping on the emergency panels. That's pretty good. Then we close this up. These need to be rotated back to this configuration. Okay. The boom can stay in its funny canonical position of on top of the ship. No. You know what? I'm gonna do this politely fancier. Get my action groups. Group 1 is about to have a fun time. Here's what Group 1's gonna do. Actually, no. Before that, we need the robotics. Now, there's no point to have two aside from symmetry, so I'll just do one and then try and center it with this. Oh no, put it on top here. Yeah. There we go. Okay, here's the plan. Open editor. Go to the controller. Here's what's going to happen. When we activate this controller, we are going to deploy that seems like it's just going to be an explicit trigger. Okay, we won't do this. Only the analog parts, which is this. Target angle shall go from retracted to deployed, clamp, smooth. Smooth. Good. Good, 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 good. Do that over the course of like, say 3 seconds. We'll go like, and then it's good. Now, what else is there? Well, first off, we're going to go to Control Group 1, and Control Group 1 is going to be the play sequence button. But aside from that, it is going to be the extend antenna button, the extend solar panel button, and here's the secret, the deploy fairing button. So with that, we are going to would have liked the option to remove it from the staging diagram. Fairing not staged. We fixed it. Great. Now just at the bottom, we have the launch. Okay. So this is going to be yes. No. I'm conflicted. I would like the liaison to serve double duty as a relay. Maybe we're content with just the one. Yes, we are. You do not make it easy to attach stuff, huh? It's this interstage. Turn that off temporarily. There we go. And then just because I know this is going to be a weak point, there we are. Okay, good enough. Just like that, a lot of the fancy engineering I just did became irrelevant. How much is that? 1,000? How much are these? 400, so 800, 1632. I think we'll do the recommendation and triple it. Slice those off. Slap these up here. And here is our liaison in its evolved form. I'm gonna leave the controller for doing the stuff, even if we don't have... Well, no, we don't need the controller, we just need the action group. So stage 1 will deploy the shell and extend the solar panels, and that's basically it. Everything else was removed. At the fairing. A little taller now. Not too bad. Fine and good and easy. Any other random junk I can glue onto this? Probably not. And I want to keep the weight down. Okay, that is the liaison. Now let's make the modified liaison. Basically just a massive antenna mount on top of everything. Just enough room for 4. It's possible the liaison just sporadically placed throughout the space set, or throughout Kerbin, or this system, the Kerballer system, will be enough. Still, nice to have a backup plan. Now, this fairing I'm worried about. Oh wait, the switchyard's 19. Oops. Take the 21 switchyard and delete that. Okay. Let's get ourselves some logistics. I think this would be good as a worst case scenario. So let's launch the switchyard and see if it flips out and explodes. Okay, this is the flight of the switchyard going to bolster Kerbin's radar network and make it more reliable. In 3, 2, 1, launch. No worries about the rocket and weight, it's mostly an aerodynamics problem. And it might be a stability problem as well. I'm not liking these oscillations. Hold steady, hold steady. I think they're getting worse. Okay, prepare to stage. Alright. Oscillations have subsided. Let us now start our turn into a very, very high polar orbit. We've circumvented the aerodynamic drag problem by just going straight up. Okay, lower stage has been expended. Jettison in 3, 2, 1. If you're wondering why I haven't jettisoned the fairing, I would like to do that all at once when I can see it, so I can see that the deploy sequence goes well. So I gotta wait for sunrise. Our initial orbit's gonna be real ugly, but It doesn't matter. We have the margins to be sloppy. And it did serve a purpose. We avoided the aerodynamic problem. We deferred it to the future, at least. There's a sunrise. Okay, sun's out. Deploy fairing in 3, 2, 1. Beautiful. Cool. Now let's go to Apo and make it Apo-tastic. Overall, I think I'm going to aim for an 80 million circular orbit. We are very much above the planet. If you're wondering if I can just circularize here, the answer is no. This would put us in dangerously close proximity to maybe the moon at some point. Though now that I'm thinking about it, maybe we don't need to go full 80 million. How about 30 million? We already have the first switch yard that can service Minmus. Like the dark side of Minmus. This one's meant for interplanetary almost exclusively. Let's treat it like it. So we are at 16468. Thousand. We want to go to 1646. No, we want to go to 30 million. 515.2. Roger that. Ooh, structural stability is going pretty terrible. Maybe I should do the same trick I did last time. I turned off wheel authority on the reaction wheel on the ion stage. Nope. This is just like structural flex. We are gonna have problems. It's probably the battery layer combined with this long pivot arm. On the next version, we could maybe do with having some sort of structural strut. Like scaffolding going along the outside near the antennas. Still going for the burn, though. 515.2. We've overcut it because I was looking at what the amount was instead of actually just burning. It's fine. It's fine. I'm staging now. I cannot deal with that stage right now. So we'll go to wherever Apoapsis happens to be. It'll be slightly more than 30. I know that much. Looks like we will be enjoying a 35 million orbit. Oh, right, the control wheel. There we go. Okay, well that rotates into position. I will put in the numbers. Our altitude is 35835, and we want to circularize that. Thousand. Okay, target speed is 311.2. We are in position now. Let's us accelerate. Yeah, much easier to do a burn when we have a weaker thrust base. Ooh, they're cutting on the interior side, huh? I didn't think of that. Right, that's why I wanted to extend them outwards in the first place. Okay, that's going to require some redesigning on the liaison. It's not a problem physically, but like it's ugly that it's clipping. Or I guess the satellites are heavy. Well, the dishes. You kind of conflate the two a lot. Three 11.2. All right, good enough. Let us point ourselves strictly north-south. That'll give us a good line to the sun, wherever Kerbin is. It's mostly above us, so let's face mostly below. The Switchyard Orbital Edition is in place. And what's important is that this will be the step going interplanetary for the most part. So we will not be restricted by the previous Switchyard. Let's go to, like, we have that ground station, but that ground station can only ever be the first jump. It only helps, like, to bolster a direct line anyway. But that Switchyard will be the last jump. Okay, before I forget, let's fix the liaison. Let's fix the Switchyard. Now let's just fix the liaison. We're going to be sending a lot of liaisons. It's going to be our flagship ship for a while. Not in the sense that it's our flagship for a fleet, but like our flagship product. There's a distinction there. Alright, here we are. I suppose I'll fix it here as well. So observe. Yeah. Too close. We'll bring the I-beams back in. They're way too long. How about one of these things? I've really used these before. here. That's good distance. Lock in. Splendid. That's fixed. Support pylon's going to be tough. It might just be that the switch yard is forever doomed. Well, let's save it. Let's open the liaison as a merge. This is our diabolical scheme here. That didn't work. Let's just open the liaison. I'll rebuild the thing. Okay, lest we forget the problems we've had. I was already on the page, wasn't I? Effectiveness has already been established. We do that, and it's fine. We do that, and it's fine. Thinking maybe the electricity is not... I'm gonna add scaffolding. And I'm gonna do that by moving one of these up here. You might pretend that it is the power to the Pianui. Okay, our shout-out war has escalated, I see. You were performing escalation before my very eyes. Diabolical indeed. Anyway, welcome. I'm building my new interplanetary ship probe. Needs scaffolding because it is tall. Space travel is going alright. We've made it to Duna, but in very inclement conditions. Radar coverage is pretty terrible, and Ike makes me scared of getting anywhere near the surface, which I need to if I want to get good data and numbers. So I'm upping my infrastructure to improve it. You know, more ships with better satellite dishes to relay control. And hopefully that means I won't have to worry about the finer details. So this is the new liaison. Unfortunately, we can't use the new liaison because we already have the old liaison still in orbit of Duna. Let's see if our newly acquired radar coverage infrastructure back at Kerbin will help us control it better from where it's stuck now. But it is there, it is stable, it is safe. We have numbers. We have a plan. It's going to be a hard, difficult journey to improve getting the ship there. But at the very, very least, we got one. It is no longer impossible. And that's a big step. Also, not to imply that Pianui is the only one here, welcome everyone else who raided. There's a lot of you. I don't remember my world record for largest raid into myself, but that right there, that was pretty high up there. I know Acela got a crazy one, but that's not me. Okay, so we're back here. So this is direct signal line to Kerbin, but what if we rotate the planet? We should see the switch yard come up here as an option soon. Yep, okay, we see it. The switch yard is in play, and it can reach us. It can barely reach us, but it can reach us. That's good. I feel strongly that the next iteration of the liaison will have a much stronger signal. Okay. Next order of business is I want to get a very, very rough estimate for the standard gravitational parameter of Duna. This will give us some bounds. It'll let us know how close we can get and what speeds we need to do to get there. Yeah, look at that. We have perpetual signal, basically. So I'm going to have our timing point be when we hit 30 million altitude. Oh, we're there. Okay, so we're going to be using the universal time here because MET is no longer showing us seconds. For this, we go to the mu determiner and use the area up here. So, time at this moment is year 66, 315, 2, 46, 14. As is standard protocol, we're going to go for maybe like 10 orbits. And just make sure that everything is good. We get good numbers. Okay, so let's begin. Ascent at 30. That's our target. One. Two. Actually, this is going to be a rough estimate anyway. Let's just do 5. Actually, let's do 4. I mean, if we miss one, we'll just add another one on there. 3. We'll aim for 4, and if I miss, we'll still land among the Duna. Careful, we're approaching. 28. 85, 86, 87, 88, 89, 90, 91, 92. Go down a decimal point. 30. 40. We're basically Zeno's paradoxing this for convenience. 50. 60. 70. 80. Here's the moment. 90, 91, 92, 93, 94, 95. Down a decimal. 60. 70. $80. 90. 91. 2, 3, 4, 5, 6, 7, 8, 9. We're there. Okay. What's that time? 67,203. Also, let's do this. 4 orbits. We did 4 orbits here. Current time is year 67. Day 203. Hour 0, minute 10, second 46. Oh, I forgot. We need our periapsis and apoapsis as well. Conveniently, these are the same orbital parameters as part of our radius survey, so we can simply take these and slap them over. There's periapsis. There's apoapsis. And with this, we are getting a calculated standard gravitational parameter for Duna of this big ol' value, which we shall immediately put into our in-use category with a... Wait a minute. Ah, they almost got me. I forgot to set the planet radius. And that's what we're getting from the radius survey. So radius survey says it is 291,000. We put that here as the planet radius in question. And now we get a mu value of this. That makes a bit more sense. So we'll put that into here as the SGP. We are going to color that red because it's a very bad estimate that we're just using right now to be able to perform any function whatsoever. Would you please interpret that as a number? Thank you very much. Let's fill that red. Even the radius I don't feel comfortable with. That's also going red. So goes it. Still, though, this is the data. And so we can go over here. We can insert another column. We're running out of these. And put in Duna. Just duplicate over all this. Thank you very much. But put in our own numbers for everything. Current planet radius estimate is this. SGP in question is this. You know, SGP is pretty close to Kerbin's value, at least at this estimate. Wait. No, scratch that. It's like off by a factor of 10. Cool. Well, anyway, we can now use this to roughly get closer to Duna. Our big fear is still Ike, but I think we have what it takes to sort of dodge Ike here. I want to do this at a time where we're going to be facing the same direction. I don't have a good sense of, like, where Ike is. So how about we go down to 10 million to start. Get some instincts here. So right now, we are at 28530,000. We want to go to 10 million. This would require a velocity of 74. You know what? I'm feeling... No, yeah. 10 million. 10 million. Be safe. Be reasonable. Target speed, 74.0. This will also... Oh, we're not even at apoapsis. Hold on. I gotta wait till one of the apses. Getting sloppy. Our relative velocities are so low, I could have just made that an apsis, but I think we should be responsible. Close enough. Okay. Quick alteration on the numbers here. It's 23690 to 10 million. For a target speed of 86.7. So it shall be. Now that we have the new liaison, I feel like I'm operating an outdated vehicle here. .7, we time warp. All right, let's see how good of an estimate we've got so far. We warp down. Hello. Wait a minute. I recognize those syllables. Also, hello. You got words for names. Okay, I accidentally passed the periapsis while I was talking to a person. Oh. Okay. Maybe cool the brakes there, exception. Duna ain't going anywhere. Hold. Wow, I am surprised at how functionally accurate that was. We're pretty close. Okay, I'm gonna go for the big risky descent. What I tried to accomplish is okay, long term, like overarching, I'm trying to do a bunch of stuff in Kerbal Space Program without using the map. It's not even available to me. I press the button and it just does that. I modded it out myself. Short term right now, I'm trying to learn the mass of Duna so that I can more accurately determine or like plan orbits based on my velocity. And that's going to require me getting closer, but I'm afraid of Ike because it's scary. That's the basics. So we are at 9955,000 right now. And let's go to 200,000. Try and cut through Ike to the core. Well, what's scary about Ike is that it's large relative to Duna and it's very close. So if I try to get close to Duna, Ike will intercept me, use its gravity to throw me off course, and at that point, I don't even know where my orbit's going to end up. But we're going to go for it. Ike is the moon of Duna right over there. You can see it. It's the little gray circle next to the big brown one. That's Duna, the bigger one. Okay, so targeting current altitude, go to 200,000. Target speed is 51.8. We proceed. No worries. 1.8. It happens. Okay. And this is our first time getting interplanetary without the map. It took quite a bit of effort. And now that we're here, I do not want to squander this opportunity. Oh my goodness, we're out of power. We're power stalling. I forgot we are running an older model of Liaison again. Okay, 88.0, 51.8. Let's run the engines a little more. Is there any throttle level where we're gaining power? No. Okay. We're going to have to lose the efficiency of this burn a bit. I need more electricity. These Xenon engines are power hungry. Okay, that'll have to do for a bit. 51.8. Nope, we've lost power again. Can I, like, reorient? This is the worst possible orientation to be doing a burn right now. All of our solar panels are radially attached, pointing forward or backwards. They can't rotate to hit that. I can rotate to hit that, though, so maybe I just do this for a bit. Do that, time warp a little bit. Much better fuel. Okay, flip back. Return 51.8 as described earlier. Too far. Spin us around. That's tragic. It also sounds like the plot of a novel that I've been told about. Okay, moment of truth. Descend. Ike, how we playing this today? Oh, this is gonna be close. Are we good? Are we good? I think we are good. People of the jury. We are good. Okay, we have a glaring problem, though, and that's gonna be... We're still bound by Xenon. It's about to be dark. We need to slow down now. Okay, so hypothetical 200,000 orbit. How much do we need to circularize? 782. I've got concerns. I think the plight of Ike is still upon us. Okay, given the circumstances, I think the most likely outcome is that we run out of electricity, fall behind the planet, can't charge electricity, and then swing around the backside into Ike's face. Which is unfortunate. Give it everything I've got, though. Target is 782. Doesn't help that we're going retrograde through all this. Is there any thrust we can give that won't kill our power? Yeah. We can go that fast. Even that's iffy. We're not even decelerating. We are. We're just... Gravity is stronger. Oh, solar panel production's going better. Are we rotating? We are rotating. Because we're holding retrograde and we're arcing around the planet. So I can up the thrust. We have hope. We have a little bit of hope. We're going to run with it. Okay, we're not going to have enough time. The sun's going to go behind the planet, and then we're out of power. Throttle up, throttle up. Okay, we have to hope it's enough for now to dodge Ike, to stay under Ike's orbit. Real iffy, real iffy. I'm gonna burn till I can't burn no more. But sunset is approaching. .848. We're about 100 meters per second off. Actually, it's closer to 50. We might make it. Nope. It's sunset. We are at the whims of the cosmos now. It's not really whims, it's very predictable. We gotta wait till sunrise before we can do anything else. Okay, we're back. And this is a much better angle. Full throttle. Wait, this doesn't even help me. I don't even know what our parameters are right now. If we're going to do this, we need to do this right. Radial in. Thank goodness for the switch yard. Our vector is barely moving, but it is moving. Out of power. Recharge. Charged it. Radial in. Keep going. Hold. Hold. Stop. We're here. Okay, recalculate our orbit for our current altitude. We are at 538461. For, let's just say 500,000. Just circularize. Just keep us safe. 594.5. Wait, we're under. Huh? Are we good? Hundred thousands. 518. We are under that. What's zero at right now? 433. Okay. How about 100,000? 41. Okay, well, let's go to that then. 41.6. Okay, I think it's time to do the survey in earnest. Let's go to Apoapsis and see what the biggest number is. We're gonna do this piecemeal, like the olden days. Five, 3, 8, 4, 5, 4, 4, 5, 5. 454. 538455 is our apoapsis. With an error of 0.5. Thank you. This is another do not take. I missed our velocity, but we're doing it piecemeal. So we're going to go to the other side and look at our periapsis numbers. Okay. 51, 50, 48, 47, 46, 45. 45. 103445. With an error of 0.5. Okay. Piecemeal continues. We go back to apoapsis and see what our velocity is. I missed it. Okay, we'll do it at periapsis first then. We are now looking for the highest number. .976.3 looks to be it. Classic 0.05 error. There's not really a situation where the error would be anything else. Okay, Apo. All right, 3. You can still see the velocity. I'll keep the tab up. 481.6. Okay. 481.6 with an error of 0.05. Significant figures here is going to be 4. This is clamped by our low velocities. If we could get a velocity over 1,000 for both sides, we would be able to do better. Unfortunately, we cannot. There's just not enough mass. Oh! Oh, hello! that is decisive. I think we have a dev number on our hands. 320,000. Give or take 100. What happens if I put the sig fig to 5 arbitrarily? Alright, so the error doesn't descend, but... Cool, yeah, no, that's official. I'm putting that in. 320,000 exactly. Radius of Duna is 320,000. And I'm making that one green. There we are. Okay, with this, we can get a much better measure of our SGP. Also, let's put this in the APPE calculator here, just for later. Now for mu determination. Planet radius is this. I like remove formatting. I guess they're blue now. Oh well. If I do like that. Null border. That works. Alright. For this one, what number are we going to use? How about we use the rising to 500k as our timer? Okay, close enough. Universal time, let's start plugging these numbers. So, start time is 67,354. To 1920. Now let's go for some orbits. How many are we gonna do? I don't know. At least 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. Alright, let's bring it on home. Two, 3, 4, 5, 6, 7, 8, 9. I think that's about as good as we could possibly hope for. Okay. So, 67,357. Zero 3811. Okay, and we did 10 orbits. Our periapsis and apoapsis should be identical to our radius survey, so I will use those numbers. For a calculated mu value of this, which, based on the fact that it starts with a 3, looks pretty similar to the one we had before. Let's put this into our SGP calculation. Yep. Old 300 is now 301. Cool. It was already pretty close. In fact, this is probably the best SGP we've ever calculated. I'm going to make this that green. Pretty good stuff. We don't know the SOI radius, and we won't know that until we leave. All that said, though, we've gotten the thing we wanted from here. Orbital data. Parameters. And while we're still here, let's get some science. I reckon this counts as low. Magnetometer report. No, we're still high over. Let's go to 100,000 then. Report. Now that's some science. Trace magnetic fields are magnified by the sensitive instrument, yet measured in real time. All that data is looking good. Let's observe the mystery goo. Transmit that. Log ravioli. Size mix unavailable. Temperature is good. Pressure is good. Transmit all of that. Splendid. We've got Duna. We've also got a stream that's been 6 hours long. I think I'm gonna stop there. I could try and like do a crazy flyby thing to go get Ike, but we're going retrograde. That's gonna be a pain to decelerate, and it would take a long time. This is fantastic, though. We have the data. We really do have the data. We've managed to get to Duna. Oh, you know what I need to do? I can prepare a thumbnail for this. Let's go radial out. Let's do this, and then do that. That looks good. I like that. Oh, lost the plot a little bit there. It looks nice. Oh, that looks even better. It stopped looking better. Yes. Okay, I've had my fun being silly. Making silly thumbnail. I'm gonna go. This has been greatly successful, but I gotta go. If you are interested, the Rubicon Fight Club open lobby will be starting in a few hours and running for the hopefully nominal amount of time of 24 hours. If you play Armored Core 6, come stop by. If you're a member of the Rubicon Fight Club Discord, you can have your emblem added to the RFC lobby bot by posting it in the relevant place on the Discord. I don't know why I'm doing this whole fancy advertisement thing for a completely different stream and a completely different game. It's probably because I don't actually talk on that stream, because it's automated. I just sort of make sure it's not broken. Back to Curb for a second. This opens the floodgates. We can now go interplanetary. I'm real happy about this. But it also means that our work has now officially only just begun, as opposed to being done with. Here's to more science, more planets, expanding our reach to the entire system. I'm Exception. This is in TV. Have a good day, and good night.